Yes. Good evening, everyone. I am Muskan. So today we will see machine learning using Python and Scikit-Learn. Okay. So I hope my screen is visible to you guys. First of all, what is machine learning? Okay. Machine learning is a field of study that gives computer the ability to learn from experience data or the past data, we can say, without being explicitly programmed. That is nothing but your machine learning. And machine learning have the powers everything from Netflix recommendation to the self-driving cars. Okay, all these things are done by using machine learning code. Now we will see the different type of machine learning. First we will go with the introduction of the machine learning. Okay, so we are having three types of machine learning. Okay, first is, we can say, supervised learning. Now, what is the supervised learning? Supervised learning is nothing but where we know input, we know output, which is nothing but the supervised learning. So we are having some example here for the supervised learning. We can say spam detection is one of the example of the supervised learning. Next, we can also say credit scoring. So this is nothing but the example of the supervised learning. This is the first type of machine learning. Okay. Next, we will see the second type of the machine learning, which is nothing but unsupervised learning. Okay. So the unsupervised learning, in this we only know the input variables. Only input we know in this, but we unknown is output. We don't know what is output here. But in the supervised, we know input as well as the output. But here we only knows input, not the output. So this is nothing but your unsupervised learning. So in this also we are having example, which is nothing but, we can say, customer segmentation. Okay, which is nothing but your customer segmentation. Next, we can also say market basket analysis. So this is nothing but your unsupervised learning. Next, we are having one more. We can say it as in reinforcement learning. So in this, this is nothing but the learning by interacting with the environment. In reinforcement, okay. In this, what we will do here, learning by interacting with the environment. Here we interact with environment. Okay. So we can say the example of it is AlphaGo, or the game playing AI, we can say. Okay. This is nothing but your machine learning intro. So we are also having workflow for the machine learning. Okay. So what can be the workflow for the machine learning? First, whenever we will start doing the project, the ML project, we can say. Okay, so first step we go with is defining a problem. First, we check what is the problem, right? So first we need to go with the defining the problem. which is nothing but what are you predicting. Okay, this is your problem, prediction. Next, after defining a problem, we go for data collection. Okay, after collection, we prepare the data. Prepare the data in this sense. What we will do in preparing the data? We clean the data, we check the missing value, we remove the missing value, and we go for the encoding. Okay, after preparing the data, we go for choosing the model. We check different model. Based on that, we select one model like decision tree, linear regression, etc. So next, after choosing the model, we go for train test split. Okay, after that, we evaluate our model. Okay, after evaluating the model, next step will be the tuning parameter. We tune the parameter. Lastly, we'll go for the deployment. This is how we will complete our project. Okay, this completes your intro of the machine learning. Now, next part is the Scikit-Learn. Now, question comes, what is Scikit-Learn? Scikit-Learn is nothing but, it is also known as sklearn. Okay, sklearn, which is we can say that it is a free open source and very popular Python library. For what purpose? For machine learning. What it is? It is free, open source, popular library for what? ML, which is nothing but your machine learning. Okay, so we are having different features for the sklearn, which is nothing but your Scikit-Learn. Okay, the feature is nothing but it is easy to use, standard data sets, pre-processing tools. We are having huge collection of the machine learning model, regression, classification, clustering, etc. Model selection and validation is also there in it. Next, evaluation matrix, integration. Okay, these are nothing but the feature of the sklearn. Then we are having common modules of the sklearn, which is we can say that whenever we will go with our data set, at the time what we will write, if we wanted to write the code for it, we will write sklearn dot data set. We can write sklearn dot model selection if we are selecting the model underscore selection. If you are doing the pre-processing, sklearn dot pre-processing, sklearn dot linear underscore model, sklearn dot tree, etc. So like this, the common model of the sklearn. Next, okay, next we will see some coding part of it. This is nothing but your theory of sklearn and the machine learning. Hope you understood these things. Okay, now we'll go with the coding part. So here I have mentioned some of the libraries. Okay, first library is nothing but NumPy. We use NumPy library for the numeric calculation. Okay, so what we are doing here, we are importing NumPy as NP. Okay, which is nothing but your numeric calculation. By using NumPy library, we do the numeric calculation. Next is the pandas. Okay, panda as PD. So we are giving one small name panda as PD and we are importing pandas here. Import the pandas library for the data manipulation. For the manipulating the data, we use panda library. Next, we are also, what we are doing, we are taking sklearn. Okay, we are working on the sklearn library dot data set because we want data set and we need to import it. So we are taking the data set name as load underscore iris. This is nothing but iris data set we are taking. Now I'll give the example of the simple data set we have taken and we will go with that. And I'm also importing the library sklearn dot model selection. Why I'm using this? To select the model, or we can say import the function to split the data into training and the testing. We are importing training and the testing after selecting the model. Okay, next I'm selecting the model as decision tree, which is nothing but selecting or the choosing the model by using what? Scikit-Learn library, scikit-learn dot tree, decision tree. So that's why dot tree I have given here. Next, I'm again importing the function to evaluate model performance. So what I'm doing here from sklearn dot matrix import accuracy underscore score comma classification report. So these are our few libraries we are going to use in this code. Okay. So now first I need to upload my data. So I'm taking the variable called iris underscore df equals to pd dot to read that file, read underscore CSV. So I need to import it first. So I need to go where my data set is available. So here is my data set. I'm taking this copy as path. Okay, once you did copy as path, get back to the code. Okay, here is your code. So paste it here. Okay, this is nothing but your day path of your data set. So I'm using which data set I'm using here? I'm taking sample of iris data set. Okay, I'm taking the variable name as iris df. PD is nothing but our panda library, and we are reading the CSV file because this is the CSV. That's why PD dot read underscore CSV. Next, what is this? This is nothing but we can say loading load CSV file. Okay, next. Now we need to select the feature, which is nothing but features and target. We need to select the input variable as well as the output variable. Features are nothing but our input variable. Target is nothing but our output variable. Now, x is nothing but my input variable. I'm selecting iris underscore df. Then I need to select my input features. So what are the input feature I'm having? So I'll show you first the data set. I've taken the sample data set of it. Just see here. So this is nothing but our sample data set, which is having the input column as sample length, sample width, petal length, petal width, and target is nothing but my output variable. This is my input. Sorry, this is my data set. The sample of the data I have taken. Okay, next I need to keep here in the x, capital X is nothing but my input variable. So here I need to separate my input data. Okay, sample underscore length. I am first checking the length of it because this is my one feature. Next, I'm taking sample width. Okay, next I'm also taking petal length. And I have to take petal width. Okay, this is nothing but my input features. Sample length, sample width, petal length, petal width. Okay, next my input is done. Now I need to go for my output variable, which is nothing but my y. Okay, iris underscore df. So my output variable is nothing but the target. Target is my output variable, as we have seen in the data set. Done. This is clear. Next. Now what we need to do? We need to split this data. X underscore train test split. So how we will do it? X train, X underscore test, comma, Y underscore train, comma, Y underscore test. So this is nothing but I'm splitting my data X underscore train, X underscore test, Y underscore train, Y underscore test equals to. Now I need to do the train test split. Yes, here it is giving train test split. With what variable? My first variable is X and my output variable is Y. Next, so we need to keep here some test size and the random state. So I'm keeping test size equals to zero point 0.3, comma, random state we will take as 42. Okay, this is, I have splitted the data now. Next, step 4 is nothing but we will give this name as train test split. Okay, next we'll go for step 4, which is nothing but training the model. So what we are doing here, we are training the model, whatever we have splitted the data. Okay, next to train the model, first we'll go with the model. I'm taking as decision tree. Decision tree classifier I'm taking model dot fit. So I need to take my X train and the Y train. Y underscore train. Okay, this is done. Okay, next. Next, we need to go for the step 5, which is nothing but predict. So what we will do here, we predict our data. So for that, I need to write something here. Predict is nothing but I need to write y underscore predict. I'm taking the variable, okay? Equals to model dot predict x test. So what I need to take? I need to take now test because we have trained our model on the train data. Can you able to see here x train, y train? Okay, we have taken x train and y train. So now what we are doing, we are doing the prediction. So that's why I've taken the variable name as y predict model dot predict x underscore test. Okay, so I need to predict on the test data. Okay, next step is we need to evaluate it. Okay, for the evaluation of it, we need to give the code as we are checking in evaluation, we check the accuracy. Accuracy score we check with what? With y test and y prediction. We don't want the arguments and all. So we'll remove it. Okay. So we will check it. Next. To print this code, we need to write print. So we wanted to print some code here. So I wanted to check the accuracy. So I will write here as accuracy. Accuracy, which is nothing but I'm giving the formula for it. Accuracy into multiplication of 100. I'm taking this as code 2f in percentage. Okay, done. Now I need to, which is optional. Okay, we can use this or not. That depends on us. We can take the showcase classifier or not. Next, last we need to take the optional, which is try limiting maximum depth. Okay, so already the code is available here. We can see here. This is the optional print classification report. So in this, what we are doing, we are taking the classification underscore report y test y predict. Next, what I'm doing, I'm trying the limiting max depth. So what I'm taking, I'm trying with the one more model, this model 2 decision tree classifier with new parameter. I'm doing, see here, we have taken already one train model. We have taken here the decision tree classifier, but we haven't given any parameters there. So what I'm doing here, I'm taking as model 2, the same model with the maximum depth equals to 3. So that's why again I'm taking the model dot fit x train and y train. I need to take the prediction. I need to check the accuracy. So this is how this code will be there. Okay, if I'll run this entire code, let it be. We'll go one by one then. Yeah. If I'll import only the libraries, can you able to see here the libraries? The libraries are imported. Now what I'm doing, I'm importing my data. So once I'll import in my data, so can you able to see the variable here? So this is my data which is available here. Okay. Next, I wanted to do the feature and target. I'm splitting my input variable and the output variable. If I'll do this, then can you able to see here X and Y. So which is having, see the dimension. Before it was 10 comma 5. 10 comma 5 is nothing but 10 rows and 5 columns we were having. Okay. This is nothing but rows and column. 10 rows we are having. In that we are having 5 columns. This is our main data. Okay. So, but when we split the data X and Y, now see what is going on. Now it will become 10 comma 4. Before it was 10 comma 5. Now it is become 10 comma 4. Why 4? Because we are not taking the output variable. Here the fifth one is the output variable. So that's why we are taking only up to the input variable. And see the Y. Y is only 10. Means we are having only single column with the 10 rows. Okay. Next we have train test split. If I'll run this code, then it is splitted now. Now we will go with the training the model with the decision tree and I'm predicting it. Yes. See, it is giving me the prediction, okay? But I wanted to hyper tune it. Okay. So the next step is evaluation of it. If I'll do the evaluation of it, I'm getting the accuracy for the this model decision tree classifier. But I wanted to do the hyperparameter tuning to it, but still I'm applying one optional step, which is nothing but show classification report. Yeah, can you able to see this? Here we are getting precision, recall, F1 score as well as the support. So now we will run the final code of it with the hyperparameter tuning. What hyperparameter tuning we did here? We have taken max depth equals to 3. So you got here the accuracy of it. So how much accuracy you are getting with the maxed up? This is nothing but our best hyperparameter with the accuracy of the 100% we are getting. Okay, guys. So thank you so much, guys, for joining the session. Thank you so much.